Hello viewers, today we are going to discuss about vanishing gradient problem. So what is vanishing gradient problem actually? Imagine I read a book and after completing whole book I just try to remember the first sentence. It is hardly I can remember the first sentence because human memory fades over time. RNNs also struggle to retain information from earlier time steps due to the vanishing gradient problem. So RNNs are widely used for sequence-based tasks like natural language processing, time series forecasting, etc. So vanishing gradient problem occurs during training period of RNNs and it prevents RNNs from long-term dependency. So vanishing gradient problem occurs when gradients used to update the weights during the backpropagation and gradients become exceedingly small. So that's why almost no updates from earlier layers and leads to slow learning. That's why RNNs struggle to capture long-term dependency in sequential data. So before going into recurrent neural network, let's discuss about our basic neural network or vanilla neural network. So this is one of the feed-forward network. You can see there is an input layer in yellow, hidden layer in green, and output layer in red. If we pass our input with the relevant weight to the hidden state, it is multiplied and passed through the activation function. If it function to give an output, and we will calculate loss to see how much our prediction is accurate. And to minimize the loss, that we need to update our weight through the back propagation. So this is called back propagation. So we can see in forward propagation what calculation is happening. Like we can see here forward pass. In forward pass, our main equation is weight multiplied to the input plus bias, and with the activation function it gives the output. So what is the loss function calculation? So this is this is the equation to calculate the loss. What is happening in backward propagation? Actually we are calculating our gradients here. Gradients is actually the loss function with respect to the weight, and here we use the chain rule of derivatives, and we can see here multiple gradient or derivatives is multiplied together. One easy example we can see here, like if we multiplied 0.03 multiplied by 0.05, it gives smallest number. So in this way, how much we multiplied, and we'll get the smallest number in result. And what is the equation for updating the weight or updating the parameter? As we know, our parameter is only weight and bias. So we need to multiply this derivative with the learning rate. We know that it is a pretty small number, like 0.001 or 0.0001. So if we multiplied it with the derivative or gradient, it will become a very small number. And it is the recurrent neural network. And if we unfold it, we can see there are so many individual neural network. There is a weight multiplication also happening here, but here you can see there is a additional weight or additional layer, what is called hidden state. This is the mechanism or the state by which the information from the previous step is passed through the next step. In this way, the information is going to the end. But problem is multiplication is happening repeatedly with the same matrix, and ultimately the result become almost vanish or zero. And as we know, there is a loss function after getting the output. So in this recurrent neural network also we have several losses which we need to multiply together. So if we backpropagate it, what will happen? So anyway, we know that in the individual neural network, due to the multiplication, the gradient become very small number. In this recurrent neural network, also from n to beginning, there is also a back propagation in hidden state with the weight matrix. Repeatedly, it is happening. So due to this weight multiplication repeatedly, actually this vanishing gradient problem is happening. So just for example, you can see if we want an output based on the input from the earlier stage, due to this vanishing gradient problem, the recurrent neural network might forget what was the input in the initial neural network. It is a problem where the RNN struggle to capture the long-term dependency. This is the formula. This is the formula for forward pass, where we can see there is a hidden state, which is updated using the same recurrent weight WH, and this is the output where actually the hidden state multiplied with the weight plus the bias. So through the activation function, we are getting output actually. What is happening in backward propagation or backward pass? Here main thing is the gradient multiplication, repeated gradient multiplication. So gradient are propagated backward in time, computing derivatives at each time step using the chain rule. The gradient of loss function L with respect to the weight is computed recursively through this formula. So the main concept is in this case, the weight multiplication is repeatedly happening, which is actually the main reason or responsible for the vanishing gradient issue. This is the same formula. Ultimately, if the weight is large, then we will face the gradient explodes problem. But main problem we are facing, that is if the weight is small, less than 1, then the repeated multiplication makes gradient totally vanish. What is the solution to vanishing gradient problem? There are couple of solutions like activation function, parameter initialization using gates, but we will discuss about the gates, which is LSTM. LSTM networks rely on a gated cell to track information throughout many time steps. It was especially designed to address the vanishing gradient problem in traditional RNNs. So main thing is happen, it is control the flow of information, and using a set of special mechanism called gates that regulate updates the hidden state and the cell state. I will discuss about hidden state and cell state later. Just an example, we have a sentence like Rana likes biryani very much. So we can understand that his favorite cuisine is Bangladeshi. So this biryani, actually to give an output of Bangladeshi, we need a word like biryani. So in this case, you can see Rana is not necessary, so there is no information taken by cell state. Likes is not taken by cell state. Biryani is taken by cell state, and the cell state retains this information up to give the output. Let's make it more complex. Like Rana likes biryani ... So his favorite cuisine is Bangladeshi. His friend John loves pastas and cheese. That means his favorite cuisine is Italian. So just see now the cell state also keeping the biryani to the next layer. So if I go to the next sentence, his is not important, so it is not updating. When it comes to the pasta word, so it forget the biryani and keep the pasta in cell state. Later, when it comes to the cheese, it is not forgetting pasta. Instead, it keeping both pastas and cheese. When it comes to the output, so based on the pasta and cheese, we are getting output like Italian. So the concept is, sometimes we are keeping some information, sometimes we are forgetting some information, sometimes we are keeping both information. So this is actually the LSTM main concept. There is a couple of cell gated cell. So we are discussing about that. We have 4 key components of LSTM. Number 1, cell state. It carrying the information across many time steps. For get, it decide how much information should be forgot and how much information should be remembered. And input get, it determines which new information to store in the cell state. Output get, it decide what information from cell state should be passed to the hidden state. And output. In short, if I tell about the forget get, it looks at the previous hidden state and the current input and produce a value between 0 and 1. So if the value is 0, then everything is forgotten. If the value is 1, then enter previous cell is written. And what does the cell state do? Cell state is updated by combining the forgotten information and the new candidate information from the input get. So what is input get is doing? So input get decide what new information to store. Output get. So in output gets ensure that only the relevant information is passed to the next time step. We will see the Python implementation of vanishing gradient problem. First, I have imported necessary library. So next I created the sample text data to predict the last word. So you can see here I have taken the same text what I have used in my PowerPoint. So first I have to do tokenization. So actually machine learning model cannot work with the word directly, so we need to convert it to the number. And for recurrent neural network, we need to make this word in a sequence. So that's why we have make the sequential data. Why we have used the padding? Actually, if I want to see like every word convert to the number like 11 to next word like 11 to 12 in this way. So some are 2, some are 3, some are 4 in this way, but we need the same size of the data, sequential data. So that's why the gap is filling by 0. This is called padding. And after that I have split it into the x and y value. Y is actually the last word. Okay, so I have built a model called RNN model, and I will track the gradient, how it is actually changing. So this is my RNN model. After that I create this function to get the gradient value and add in this empty variable gradient log. After that I have used 10 epochs. If I run it, I found this graph. So here you can see the gradient is big, the gradient magnitude is reducing. That is actually called vanishing gradient. Although there is increase, I think it is I have used a smaller data set, that's why maybe. So if I just use the LSTM instead of the RNN, what is happening? Same, just I change this model. Instead of RNN, simple RNN, I use LSTM, and everything other is same. And if I run it, yeah, after run I got the gradient value or gradient magnitude is increasing. Okay, if I want to see my model is working or not, like I created this function, it is to predict the last word. So if I run it, I'm giving input up to that Rana likes biryani, so we can understand that, and our expectation would be that my last word will be his. Let's see what my model is giving. So here I'm put and enter. Oh, my both model is predicting same, like his and his. Option. And I have actually studied, I have taken information from this website and this is super, and also this YouTube I use. So thanks for watching.